look at your chart that should be mostly filled out. When we're looking at these measures, what's the first thing you notice? Look at measure AD. Look at measure AD for the rectangle. When you look at it compared to the other two measures that follow it, it should be longer. It's a diagonal. But when we look at it here, it looks like 3 3/4, and about 1 and some change. What are some predictions that we can make? What do you think the relationship between side AE and side AD is? Corbin?
AE is half of AD.
That's right. AE is half of AD. How did you know that? How could we figure that out? Great news. For every parallelogram, the diagonals bisect each other. They cut each other in half. This is true for rectangles, for squares, you can see, for rhombuses as well. What about for trapezoids? What about for trapezoids, Evelyn? Are you sleeping? Put your head up, or I'll take your chair. You have two options. You can sit up now, or I will take your chair. Thank you, ma'am. All right. What about for trapezoids? So we know that for rectangles, we have two diagonals. Here's one of them. Here's half of another one. And look, it's half. They bisect each other. What about for trapezoids? We have one diagonal, and we have where it intersected with the other one. But is this half? No. Not at all. That doesn't make sense. So our rule that we'll be working with today, it works for rhombuses, it works for squares, it works for rectangles, but it does not work for trapezoids, because our trapezoids parallelograms? Class, no, trapezoids are not parallelograms. Go ahead and flip over to your key points. Everyone should be on the key points page. Pencils in your hands, ready to follow along as we take notes together. Pencils in hands, ready to follow along as we take notes together. Wonderful. So looking at the key points page, Chris, can you read the first sentence, please? The diagonals.
The diagonals are parallelograms like each other, so cut each other exactly.
We already know that they cut each other exactly in half, so we know the second blank. So go ahead and write half in the second blank.
Is the first one bisect?
Is the first one bisect?
Yeah.
Who says yes? Raise your hand if you think the first one is bisect. I have a bunch of hands. Surprise, surprise! The first question, I'm sorry, Chris, or Nick. The first question, the first blank is bisect. Bisect. Bisect means to cut exactly in half. We can use this property to solve equations. Our first step in solving these problems, I'm on the second paragraph of the notes. Our first step of solving these problems is to figure out which equation we should use. In this case, we know the basic premise is 1/2 plus 1/2 equals 1 whole. So those are your next blanks. 1/2 plus 1/2 equals 1 whole. And that makes sense. We've just seen that. That makes sense.
Oh, half and half.
Yeah.
1/2 plus 1/2 equals 1 whole. T, will you read the example for us, please?
Miss Weldon is stuck in her pet parallelogram mark. She's walking her pet parallelogram. She notices some interesting markings on Mark's diagonals and wonders what value the H represents.
So we are going to be solving for what? The value of which? solving this problem together. So the first step in solving our problems, and you should be writing these with me, our first step is writing down what we're looking for. So we know that we're looking for x. X equals blank. Put that at the top of your page, so now it's a fill-in-the-blank problem, and you know exactly what you're looking for. X equals blank. What's our next step? Well, we know 1/2 plus 1/2 equals 1 whole. So we know that KW plus WA, I'm looking right here, KW plus WA equals this whole line, so line KA. We don't know the value of KA though. Are we stuck? No, we are not stuck because we also know something else. 1/2 equals 1/2. So we can also say that KW equals WA. KW equals WA. And we know these two expressions, so we can set them equal to each other and solve. So we will set KW, which is x plus 40, in parentheses, equals 2x plus 18. 2x plus 18. Oops, this should be a plus. What's our next step? Raise your hand if you can tell me the next step. T.
Solving it or?
We want to get x. We want to find x.
Okay, add like, combine terms.
Combine like terms. That's our next step. So we can't do anything with how it is now. So we have two options. We can move over an x, or we can move over, which should we move? Let's go ahead and bring this 18 over to this side. Question? Please raise your hand if you have a question. I'm happy to answer them. All right, so we're going to move 18. Remember, we need to do the same thing on both sides. So we're subtracting 18 from the right side. We're subtracting 18 from the other side. We know that 10 minus 8 is 2. This becomes a 3. Oops, 22. And this plus sign comes down with us. So we know that x plus 22, that's a 22, equals 2x. Equals 2x. Now what do we do? We have an x on this side that we need to smush over here. So we subtract the x over here, subtract an x over here. We have x, we have 22. 22 equals x. Now we ask ourselves, is that the answer we're looking for? Yes, it is, because we have already written what we're looking for at the top. So x equals 22 is the value of x. How could we check it, you ask yourself, because you are concerned with making sure your answer is correct? We can substitute to check. So if we wanted to make sure that these were correct, we would substitute x back in to each equation. So x plus 40, that's the KW. What does that equal? 62. 2x plus 18, so 2 times 22 plus 18, what does that equal? 44 plus 18 equals 62. So does 1/2 equal 1/2? Yes. So we have solved this equation. Pretty simple, basic premise. It's the algebra we've been doing all along. Now we're just applying it to diagonals of parallelograms. Any questions? Questions about how we got this answer?